Hello everybody, I welcome you all in Sakshi Gopala chemistry classes. Dear students, in our previous video class, we have already dealt with a set of 10 questions which are basically categorized as the conceptual building questions that are going to strengthen your basic concepts in solid state. Now in this video class, I am going to deal with another set of 10 questions with an increasing level of complexity. So dear children, let's begin our today's class. Dear students, let us see the first question. This is question number 11. Let us read. A solid AB has a rock salt structure. If the radius of cation is 120 picometer, what is the minimum value of radius of B minus ion? Okay, this is the question. In the question it is given AB is a solid that is having a rock salt structure, means that it is possessing the structure similar to NaCl. Now dear children, what is asked? What is the minimum value of the radius of the anion? So see how to solve this question. We know that in a rock salt structure is the structure of what? NaCl, right? Rock salt structure. There, the radius ratio lies between 0.414 to 0.732. Now dear children, radius ratio means radius of cation divided by radius of anion. Okay. Now which value we have to take? See, we are taking 0.414. Why? Because in the question it is asked what is the minimum value of the anion. So we put this value 0.414. Now solve it for, when you take the radius of anion to the right hand side and substitute the value of radius of cation, it is given 120 picometer, right? And you divide it by 414. Now set up the decimal points. Okay. Now see, 120 divided by 414. You are getting 289. You are getting 289. And what will be the unit? See, the unit of the radius of cation is picometer. So यहाँ पे भी unit क्या होगा? Picometer. So the correct answer is C. Now dear children, see the next question. Question number 12. Here you have to choose the false statement. So let us read statement one by one. What is given in the first statement? Option A. Octahedral void is formed at the center of 6 spheres which lie at the apices of a regular octahedron. Is that statement is correct or false? Octahedral void is always formed when octahedral void is formed at the center of a 6 spheres. Okay, तभी तो उसका coordination number क्या हो जाता है? 12 हो जाता है. So the very first sentence is correct one. Now there is a 2 tetrahedral side for each sphere. Dear student, this is also correct if suppose there are n number of atoms present in a lattice, then the number of tetrahedral voids is 2n, that is twice of n. Now dear children, let us see the third option. There are 1 octahedral side for each sphere. Is that true? Yes, this is also a true statement. Why? Because the formula for calculating the number of octahedral voids is equal to the number of atoms present in the lattice structure. So this is also correct one. Now dear children, see the last option. Octahedral voids, they are formed when the triangular voids in the second layer are exactly overlap with similar voids in the first layer. So this is a wrong statement. Why, student? Because octahedral void is formed when the triangular voids of second layer overlap with the first layer, but the portion which is a non-overlapping zone, that leads to the formation of octahedral void. So here the word overlap ओवरलैप के आने की वजह से ये स्टेटमेंट रॉन्ग हो गया. ओके, द नॉन ओवरलैपिंग जोन लीड्स टू द फॉर्मेशन ऑफ ऑक्टाहेड्रल वॉइड्स. सो डियर चिल्ड्रंस, इस क्वेश्चन का करेक्ट आंसर होगा ऑप्शन नंबर D, because this is a false statement. Now we have the another question, question number 13. See what is asked in the question. In CCP means cubic close packing arrangement, the pattern of the successive layer is. So we know it cubic close packing is also called as FCC. It is the three-dimensional packing, okay, from two-dimensional hexagonal packing covering the octahedral void. So there the type of arrangement is ABC, ABC. The third layer is, we get a new type of layer, new pattern of layer, and we name that as C layer. Okay, so the pattern is A, B, C. Then we repeat that fashion, A, B, C. So this is, answer is option number B. So children, here we have another question. Copper crystallizes in FCC structure with a unit cell length of 361 picometer. What is the radius of copper atom? Okay, in this question it is given copper atom that crystallizes in FCC structure, means face center structure. Edge length दिया है 361 picometer. You have to tell the radius of copper atom. So see how to solve this question. Given is edge length 361 picometer. Now what is given? Copper crystallizes in FCC. So what is the radius in FCC is A upon 2 root 2. Now substitute the value of edge length in this equation. You will get, see, A is 361 divided by 2 root 2. Now applying the search so as to solve this root 2, we get 361 upon 2 root 2 multiply root 2 divided by root 2, so that you get in denominator a whole number. Okay, so here 361 into 1.414, that is the value of root 2. Now here 2, root 2 into root 2 will get 2, and 2 multiplied by 2 you will get 4. Now see children, in examination you have to multiply on your own because no calculator is allowed in your examination. But right now here I'm solving it with my calculator. Okay, so the correct answer is 126.6 picometer. C in the given option, C is your correct answer. It's given 127 picometer. So the radius of copper atom is 127 picometer. Now see the question number 15. The edge length of face-centered cell is 508 picometer. So first of all, let us write what is given in the question. Given is edge length is 508 picometer. Now see what is asked. If the radius of the cation is 110 picometer, the radius of anion, okay, you have to find the radius of anion. In the question it is given the radius of cation along with the edge length of FCC structure. These are the given options. So see how to solve this question. We know this formula, radius of cation plus radius of anion means twice the radius of cation plus anion is equal to the edge length A. Now substitute the value, twice of radius of cation is 110 plus radius of anion, you get 508, right? Now see, divided 508 divided by 2, you will get 2 2s are 4, then 5, then 4. Okay, 254. Now calculate for the radius of anion B, right? 254 minus 110. What you will get? 144 picometer is the unit. So the correct answer is option number D. Right, children? I hope this question is clear to you. Now, children, here we have one direct question. See what is asked in the question. Fe3O4, this ore is named as magnetite, is an example of. Okay. Now the given option are normal spinel structure, B is inverse spinal structure, C fluoride structure and D anti-fluoride structure. So ये दोनों तो बिल्कुल भी नहीं होगा क्योंकि it's not a fluoride structure, right? What is that? It is an inverse spinal structure. Now children, we have the another question number 17. See, in this question you have to choose the incorrect pair. You have to identify that option which has the incorrect or unmatched pair. Okay. See, the first option is given Schottky defect. Equal number of cations and anions are missing. Is that true? Correct. In Schottky defect there is equal number of cations and anions, they are missing from the lattice structure, so that it leads to decrease in the density of the crystal. So the first one is correct. Now see the second one about Frankel defect. Frankel defect, dislocation of cation from its normal site to an interstitial site. Is that true? Yes. Frankel defect is also called as the dislocation of cation. Okay. Now C. C is given impurity defect. Cadmium chloride in AgCl crystal to create the cationic vacancy. This is the example for the impurity defect. This option is also correctly matched. Okay. Now see the last option. Metal excess defect. Given example is Fe 0.930. Is that true? My dear children, this is a false unmatched pair. So the incorrect pair is option number D. Dear children, Fe is 0.930, this is a non-stoichiometric compound. We can never make the improper ratio iron and oxygen. So this is an example of metal deficient defect. Some of the sites of Fe2 plus ion, they are occupied by the Fe3 plus ion. Okay. So this kind of defect is called as a metal deficient defect. Now again we are having one direct question. See what is asked in the question. What type of stoichiometric defect is shown by ZnS? Zinc sulfide. So we all know that zinc sulfide is a superhit example of Frankel defect. So the correct answer is Schottky, Frankel, both Schottky, Frankel, non-stoichiometric. Correct answer is Frankel defect. Frankel defect का example होता है zinc sulfide. Now see children, here we are having one more important question with us. It is also a type of a direct question. See what is given in the question about the silver halide. Silver halide, the superhit example is AgBr, which you have run in your solid state. Okay. Silver halide, they show Schottky defect, Frankel defect. Both Schottky and Frankel cation excess defect. So dear children, what is the correct answer for this question is both Schottky and Frankel defect. You get the example of silver halide in both Schottky defect also and Frankel defect also. Means the silver halide, say for example AgBr, it shows both the defect at the same time. Now this is the last question of this set. See, an electron which is trapped in an anion site in a crystal is called as, the given option है F center, Frankel defect, Frankel center, interstitial defect and D is a Schottky defect. So children, we know that whenever an electron that is trapped in the anionic vacancy, anionic site, that electron is called as F center, right? And what is the speciality for this, it imparts color to the crystal when absorbs a specific wavelength of light. So the correct answer is A, F center. So dear children, this completes set 2 of our series, and in the next video class we are going to start with set 3.